David, thank you so much for taking the time to join us today, and a very warm welcome to the show.
Very glad to be here and looking forward to chatting with you.
We've got this mainstream debate, if you like, and as we know, or as viewers may not know, but as we're going to discuss, it contains in it some assumptions that are never actually questioned in any of the news reports we hear, frightening us about the imminent, climate crisis. Every time there's a hot spell here in the UK, people, start crying global warming and it's the end of the world and all this. So there are these assumptions within the mainstream debate, and you're going to help us today sort of explode some of these. Maybe you could just give the listeners a sort of brief synopsis of your qualifications.
Yes, I'm definitely not a climate scientist, but I have a PhD in electrical engineering, and the main focus of that was solid-state device physics. And having that very strong academic background in the solid-state device physics, which overlaps a lot of other physics issues, I have worked primarily in the semiconductor business in the early years of my career, but that was expanded into magnetics, fairly radically different fields. Then from there, I went into displays, X-ray image sensors, again, a fairly significant departure. And then into lasers for fiber optics, and then after that, nanotechnology. And then finally, the last 8 years or so of my career, I was working in microelectrical mechanical systems for a radically new display technology. Now, that's a pretty broad spectrum of technical issues, but having had the very strong academic background in the solid-state device physics allowed me to jump into these fairly significantly different fields and very rapidly get up to speed and start making significant contributions. When I retired in 2012, I began to dive into the whole climate issue and have read well over 1,000 papers, articles, trying to understand what's going on. And much of my comments today are based on that study and where I've arrived at today.
I think it's always useful, isn't it, to find out where someone's come from is, although I tend to dispute the actual necessity of being a climate scientist in order to understand these basic facts about climate and the historical record. And I do encourage everybody to try and stand on your own intellectual independence and think these things through. But David, perhaps the first of these assumptions we could address is that, I'll list all four of them, and maybe we'll start off with the first. The first one is that CO2 is somehow harmful. That is implicit in the mainstream story. The second is that more of it in the atmosphere would lead to this runaway warming scenario that would spell doom for the planet and for all of us. The third point is that average global temperatures are higher than they've ever been in the past, dangerously high, and therefore the crisis. And the fourth one is that atmospheric CO2 concentrations are higher than they've ever been in the past. These four claims are implicit in the mainstream story. Would you agree with that, first of all, David?
Yes, I fully agree with that. And there's a lot of evidence that runs completely contrary to all four of those points.
Well, maybe we could address the first issue then. Can you lead us through, is CO2 somehow harmful, or is this true, is this false? What do we know about it?
Well, basically, the gas CO2 is not toxic at all. And the only detrimental thing that I have ever seen associated with CO2 is that, first of all, the CO2 molecule is significantly heavier than either N2, nitrogen, or oxygen that make up most of the atmosphere. And so in very deep mines, if there's not air circulation, the heavier molecules will tend to accumulate down there and somebody might die of asphyxiation. That's not because it's toxic, but just because it excludes the oxygen. So that's the only thing that I have ever found or ever seen. And now, obviously, that's a very rare occurrent. I think other than that, the benefits of carbon dioxide are simply overwhelming from the standpoint of greening the planet. And there's a lot of satellite data that over the last 30 years plus now, I suppose, the planet has greened maybe 15%, something like that, because O2 is a very dominant key element for basically all plant life.
And I understand also, David, that with increased CO2, plants are more drought resistant. How does that work? Can you explain what's going on there?
Basically, the leaves of plants have small openings in them called stomata that allow the leaves to breathe. So the carbon dioxide that's in the atmosphere is absorbed by the leaves through these stomata. And they also have an adverse consequence, I guess, in terms of drier areas where the openings also allow moisture from the leaves to go out. And the plants have to absorb more water to compensate for that. So if there's more CO2, the openings of the stomata don't have to be as large a diameter in order to get the CO2 that they need. And if they're a little smaller diameter, then the moisture loss is reduced. So plants can make more excursions into desert areas around the periphery of the desert areas. And they don't require as much water.
I'm familiar with the idea that the planet has greened, but that I'm learning something new there with this implication for drought-resistant crops. Let's maybe move on to the second point. The assumption in the mainstream narrative that more CO2 in the atmosphere is going to lead to a kind of thermal runaway, this global warming scenario and climate tragedy for everybody. Can you talk to us a little bit about that one?
Well, if you reach back into Earth's history much earlier in time, there's a fair amount of information that's extracted from a variety of proxies, ocean sediments, along with Antarctica ice cores. But going back to the Cambrian era, it looks like CO2 was up in the range of 7,000 parts per million. And I've read several places where if you go back much earlier, the level of CO2 is significantly higher than that. But if we start with the Cambrian era, the 7,000 parts per million is getting pretty close to 20 times higher than the CO2 level is today at, 410 parts per million probably. So with that very high level of CO2, there's no evidence that temperatures got to any kind of point of thermal runaway. And in fact, at those high levels of CO2, the Cambrian era itself was probably the most prolific time for life development on Earth. The evolution rate was vastly higher then than it was prior to that or since that. And those very high levels of CO2 were extremely beneficial. Okay. No evidence whatsoever of thermal runaway.
And some people have said things like, oh, but it was different then, implying that maybe somehow the atmospheric composition or the fact that, humans weren't around in their current form somehow makes a difference there. Can you just to really get to the nitty gritty there, is it relevant, any arguments that things were different, or is it just a fact that CO2 levels were 20 times higher? The atmosphere was reasonably similar and there was no catastrophe.
In a claim like that, I don't see anything specific. Things were different. What does that mean?
Well,
tell me what specifically a person might think is different that would disrupt the physics and make it different at that time than at the current time. For the last 160 million years, the CO2 level was in the neighborhood of 2,500 parts per million, and it's been kind of a linear drop since then. And so you can go back any time between 160 million years ago and the present and say, well, what was it a couple of million years ago, significantly higher than it is today. And again, no evidence of thermal runaway. And I would challenge anyone to say, okay, what do you think is so radically different that you can't believe this data?
Is it true to say that the atmospheric composition of gases has been stable over this period of time? You know, was the relevant amounts of nitrogen, carbon dioxide, and oxygen in the air reasonably similar back into that Cambrian period?
I don't think so. I don't have a lot of data. I haven't seen any data on changes in the composition of nitrogen, oxygen, although obviously plant life has contributed to oxygen. So oxygen is probably a little bit larger percentage more recently than in significantly earlier points in time like the Cambrian era. But I don't see that a difference in the ratio of oxygen to nitrogen is going to have much of any influence on the climate in this respect.
No.
CO2 significantly higher then than now, and but still, even at 7,000 parts per million, it's a pretty small percentage of the total atmospheric makeup.
It does seem incredible, doesn't it, that the historical record, as nicely depicted on the graph there on the slide. I've seen similar versions of this historical comparison between CO2 and temperature and the trends. It seems almost mind-bending that this can be true, and yet it flies so in the face of the official story. If we can see here that temperature and CO2 have both been considerably higher, it almost beggars belief, doesn't it, that this story can stand without more of a clamour of sort of fists banging tables, metaphorically, and people, protesting.
Well, the other thing about that graph is that from the Cambrian era at 7,000 parts per million, there's been a steady, not completely steady, but a dramatic drop in the CO2 level in the atmosphere over time. And one of the things that surprised me more than anything else I think I ever read in studying the whole climate global warming issue is if you look at where is the carbon in the lithosphere biosphere. And I first ran across this in a book by Ian Plimer, who said, and I've found it other places since then, that 95% of the carbon in the lithosphere biosphere is locked up in limestone. So limestone results from ocean sea life that has accumulated and covered the ocean floor, later to be buried and subjected to heat and pressure to convert it into limestone. So all the limestone originated with sea life, basically. And so sea life has been extracting CO2 from both the ocean and the atmosphere indirectly, I suppose, to form calcium carbonate, which is later converted into limestone. And I've read some interesting accounts where long ago in the Cambrian time period, sea creatures discovered or evolved to form these really hard shells as a protection against predators of calcium carbonate. And so they've been extracting all of this carbon and sequestering it. And the steady decline actually should be more alarming to people than any contribution that we're making burning fossil fuels, increasing it. Because it'll be a serious problem if the CO2 continues to drop, because there'll be a problem with photosynthesis at that point, and all life pretty much, except for maybe deep sea vents, depends on photosynthesis for their survival.
Okay, well, that certainly explains, the historic steady decline in atmospheric concentrations of CO2, the fact that they're sequestered, as you suggest. Perhaps you can elaborate more then on the the plants' requirements for CO2, and the fact that we're now actually in a what could be called a dearth of CO2. We're at a low point. Perhaps you could expand on that.
So there are two slides, 5 and 6, that show directly the impact of levels of CO2. Slide 5 shows rice plants and what happens as the CO2 level is, in this case, artificially reduced. There's a dramatic drop in the size of the plants at about 200 parts per million. And once you start down to 100 parts per million or lower, you can see that the effect on the plants is really detrimental. Similarly, slide 6 shows the benefits of increased CO2 on the growth of pine tree. And there's another inset there of a different plant that is subjected to increasingly lower levels of CO2, and the stunting of the growth is just very, very dramatic there. Dropping down below 200 parts per million represents, I think, a very serious risk. And the fact that the sea life has been extracting these CO2, there's been a steady decline that eventually will lead to the extinction of life if the CO2 is not replaced. There's a inset of, that shows the CO2 level. If you go much further along to slide 11, shows this steady decline, and there's a little inset of what the decline would be without humans burning fossil fuel. And with the burning of fossil fuel, we're bringing it back up. So this is buying life a little bit at a time, but the fossil fuel reserves are limited, and there's still down the road, longer than our lifetimes, obviously, some risk to that. Looking back at the fourth slide, there's another interesting point, actually two here. One is that there's absolutely no correlation between CO2 and temperature, but about 300 million years ago, there's a very strong dip in the level of CO2 that went down to below 180 parts per million. And this would have been a very detrimental situation for photosynthesis plant life at that point in time. I have not been able to find anything on this because more recently than that time, dramatically, the CO2 level comes up. I have not been able to find anything related to what happened there. I would have to believe that it had to do with volcanism or, well, let me make one other comment. Again, from Mayan Climber, I've read that about 75 to 80% of all the volcanism on Earth is occurring under the ocean. Obviously, we're not monitoring that. We don't know what's going on there. There's deep sea vents and that sort of thing. I would have to believe that the rapid increase in CO2 following that very minimum time period would have to be coming from some volcanism that is bringing CO2 up to the surface from much deeper in the mantle. But again, I've not been able to find anything on this. I just, that's a point I'm very curious about. Okay, so slide 7 is looking at much more recent time period on the temperature. And within the last 150 years, there was a high point, at least in the U.S., doesn't show up so much elsewhere, but I believe that there's still carried over to other parts of the Earth. During the 30s, the temperatures were significantly higher than they are today. And again, no correlation with CO2. That is a point in time prior to when the consumption of fossil fuels really began to take off and the human contribution to the CO2 level in the atmosphere was more up into the 50s than the time since then. So again, this is a major point of lack of correlation between CO2 and temperature.
Just for clarity, for any viewers of this graph, the blue showing actual temperatures and the red line showing it says model average there. Is that the modeled temperatures?
So the IPCC has quite a few different computer models that are fundamentally based on the erroneous assumption that CO2 is driving the Earth's atmosphere, or the Earth's temperature, I mean. And the red squares on there show an average of 45 of these models. And in very recent time, they're departing ever more radically from reality. First of all of the models have tuning parameters that will be used to try and make the data fit some range of temperature data. But in actually private conversation with Dr. William Happer, he made the comment that there are no single set of unique tuning parameters that will allow these models to reconstruct the past temperature history that we know about.
Okay.
And because of that, if they can't reproduce the past, they obviously aren't going to be worth depending on for predicting the future. And we have quite a lot of data. Actually, IPCC has 102 models, and all of them more recently are departing ever more extremely from actual measured temperatures.
If the computer model can't take historical data and churn out what the actual climate was doing in terms of temperature and stuff, then it can't be relied on to forecast the future accurately. And I believe also, even over the last 30 years since these models have been used, that they haven't actually tracked the reality of what's happened at all accurately, have they?
No, they have not. And the departure from reality seems to be increasing. So obviously, there's a lot of problems with the models. The fundamental one being that they're depending purely on, or for the most part, depending on CO2 to gauge their future. And actually, this struck me some time ago that if you make the erroneous assumption that CO2 is driving temperature and you develop computer models based on that, if you use input data as increasing CO2, what do you think the model is going to put out? Well, the model is going to put out increasing temperature.
Yeah.
Does that prove anything? No. Absolutely not.
And that again comes back to these assumptions that we're trying to challenge here, because if these models have been programmed with these assumptions, just like the public minds or minds of people in the public have been programmed with these assumptions, you're never really going to find truth while you're operating on false assumptions.
There's a fair amount of data that shows a lot of variation with solar activity. And these models do not contain any solar variation. And also, they don't include any effect of clouds, which have a significant impact on global temperature, because nobody is really able to predict how the cloud cover is going to change. There's a number of factors that influence that. And to my knowledge, none of them really predictable, which is why they're not in the models. But that doesn't mean that because they're not in the models that there aren't significant influences occurring because of them.
Yeah. So again, with this this idea that it's never been warmer than it is today, and there's a crisis around the corner, we're all going to be dead in 12 years, and all this nonsense. What about your slide number 8? I quite like that. It's obviously, I think is that your son there in Greenland, or you've been to Greenland? Tell us about Greenland.
My son lives in Newfoundland, and his family lives in St. John's. They have 2 daughters that are my only grandchildren. This particular picture was taken in 2010. Tilly, who's riding on his back, was about 2 years old then. And as you can see, it's pretty cold how they're dressed. And we were at Lonsdale Meadows, which is a Viking archaeological site that was just incredibly fascinating. The Vikings came to what they called Vineland, but basically parts of Greenland, Labrador, and Newfoundland, called it Vineland because they found grapevines growing in Newfoundland. And there's evidence, the picture on the left there is of a church that was in Greenland. But they settled this time period during the medieval warming period, when it was warmer than it is today. From that time period, there are accounts, you probably know this better than I do, of grapevines being grown in northern England where they will not grow today.
Indeed.
And numerous other similar kinds of accounts that are hard for people who are looking for the alarmist position, hard for them to ignore some of this data. The Vikings that were in Greenland got frozen out with the onset of the Little Ice Age going into the 1400s, 1500s, 1600s. And there was a group that tried to go from Norway to Greenland. I think they arrived in 1407 trying to see if they could convert the settlers that were there to the Christian faith. And when they got there, there was nobody there because they'd all perished. Actually, not nobody, but Eskimos had moved in as the Vikings died off.
Yep.
First, their livestock died off because they couldn't raise enough food, and then they themselves perished. But it was clearly warmer at that time than it is in this area today.
And therefore, hence the lack of need for any alarm or any sort of disaster, doom and gloom stories that we should all stop using fossil fuels and cut our energy requirements by 95%, which is something that very few people seem to contemplate, isn't it, within this whole crazy debate. The actual requirements of us to reduce our energy are colossal and would mean the destruction of our civilization if we were to actually follow them. But we'll pick that thread up later. I didn't mean to interrupt your flow there, David.
Let's look at slide 9. This goes back a little further in time than the Vikings, back to when we started emerging from the last glacial period, 11,000 years ago. Since then, there have been alternating cycles of very warm periods and fairly cold periods. But it's interesting. During all this time, there are significantly lower levels of CO2 than there is today. And obviously, CO2 is not changing up and down the way the temperature is changing up and down. It's much more likely that variations in the solar output are driving a lot of these excursions. I noticed in looking at this graph, I haven't seen anybody do this, but if you look at this graph and draw a line through the maxima temperatures and through the minimum temperatures, you see that everything is declining. So it looks like for the better part of the last quite a few thousand years, overall temperatures have been headed down. And we'll see that more dramatically in another slide a little bit later. But certainly the medieval warm period is warmer than it is today. And we had the Little Ice Age, where the temperature has been rising significantly since the late 1600s, 1700, coming out of that ice age, again, when there was very little change in the CO2 level, certainly no major human contribution to it. So there's obviously something else going on that's driving the temperature, not CO2, most likely the sun. Okay, this goes, I'm going back further in time, initially 1,000 years ago with the Vikings and 11,000 since the last glacial period. If you look at the entire 4.5 billion years of Earth's history, this is a timeline that has today at the top and 4.5 billion years ago at the bottom. And there are this is just off of Wikipedia. Anybody can go see it. This isn't rocket science. You can look at the orange shaded areas, and there are 6 major ice ages. And when I first started into this pursuit of understanding the whole climate global warming issue, it seemed to me there was a lot of confusion about what's an ice age versus what's a glacial period or interglacial period. And I have found that the definition of an ice age is anytime there's ice at the poles. And you can see from the red arrows highlighting these orange shaded areas, these are the different ice ages. But all the space in between, which is roughly about 85% of Earth's history, there was no ice at the poles. And it would be hard to argue that if there's no ice at the poles, the temperature is going to be colder than it is today, that today is the warmest it's ever been. That can't possibly be true. There have been a lot of fossils of hippopotamus and other tropical animals and plants found in Northern Europe and in the Arctic areas. So obviously, and there's a lot of oil up there, fossil fuels, that had to have been accumulated during the periods when there was no ice at the poles. The normal state of the Earth is no ice. So people get so upset about, well, the Arctic is melting. Well, the normal state of the Earth is no ice there at all.
Yeah, and somehow still the polar bears, are still with us, even though they've been through these periods where there've been no ice at the North Pole or the South Pole. Yep, the facts of reality are quite revealing, aren't they? I can almost imagine the cognitive dissonance in people's minds as they try and grapple these facts with the official story, and of course it can't be done.
So in the 50s, 3 different organizations in the U.S. anyway estimated the polar bear population between 5 and 10,000, and more recently the estimates are it's between 25 and 30,000. But Terry had a humorous slide that said initially there were 5,000 of us, and now there's only 33,000 left.
Like it.
Slide 11 extracts just the more recent years from that first graph that showed the 500 million years worth of data. There's 160 million years with a steady, pretty linear decline in CO2. This is extracting CO2 to form calcium carbonate and part of the sequestration into limestone or other carbonaceous rocks. And the blue line shows a steady decline intersecting the horizontal red line that's labeled death of plants at some point a couple million years into the future. And the gray inset is human contribution, and there's a gray arrow over on the right that shows where we are presently, which is above where this linear curve is stopping. So by burning fossil fuels, we are extending the survivability of life a little bit, but eventually the fossil fuels are going to run. And then what? I don't know.
I'm fascinated by the idea, as with so many other issues out there in our culture, in our mainstream sort of cultural download. So many of these issues are 180 degrees wrong, and this is really quite alarming to think that CO2 coming down to a level at which plant life can no longer be sustained because photosynthesis can't happen. These are the facts of reality that people need to be conversant with. And it's amazing to think that it's actually completely back to front, and are putting CO2 into the atmosphere is probably, not only is it not a bad thing, but it's probably, the saving of life and the planet, or it could be as big a deal as that, couldn't it?
It could. Very beneficial, in fact. The 12th slide shows on the right-hand side the measurements that are made at Mauna Loa for the time period since about 1958 when they first started. And you can see it's a steady increase in CO2 level. No surprise, I think everybody believes that. Maybe one of the things that's a little bit surprising is that this is a jagged sawtooth curve. It's not just straight linearly increasing measurement. The jaggedness apparently is coming from seasonal variations in CO2 in the atmosphere. When spring hits after winter, plants come alive and they start absorbing CO2 out of the atmosphere at a much higher rate. And then in the fall, when they start to die off in preparation for winter, they're not consuming so much CO2, and so the CO2 level in the atmosphere goes up. But it's very interesting if you look at the temperature and compare it with this measurement. you will see that the temperature is fluctuating up and down. Obviously, in the spring, it's getting warmer, and in the fall, it's starting to get colder. But there's a 6-month lag. The temperature goes up first, and 6 months later, the CO2 begins to drop as the plants start consuming it from the atmosphere. So again, it looks like there's a reversed causal relationship, that the temperature fluctuation is affecting CO2, but with about a 6-month delay. The other thing is that the claim is made that we have never been up in the range of 400 parts per million in human recorded history. And there's a lot of data that tends to support that, but there is some data of actual chemical measurements that were made in the atmosphere in Europe going back to 1812. And there were 2 time periods when there were peaks in this chemical measurement of the atmospheric concentration of CO2 that went above 400 parts per million. If you look at almost all the data, this is, for some reason, completely discounted. My belief is that it's probably because it doesn't fit the narrative. But nevertheless, the data exists, and it shows temperature being up above 400 parts per million during the 1800s up to 1950, thereabouts, and looks to be refuting the claim that it's never been this high in recorded history. Obviously, in that first graph we looked at, we were up at 7,000 parts per million, but that's pretty far back in time. And if somebody says, well, recorded human history, that's at most 200 years, something like that. And here's some data that refutes that.
Yeah, so I think we can safely say that there is an enormous amount of factual evidence out there that CO2, atmospheric concentrations of CO2, to be clear, have been historically much higher, and there hasn't been any disastrous climatic consequence to that. What is it?
No, that's true.
The Vostok ice core data, and I've heard this cited as evidence. I understand that it's generally a data set that's undisputed. So at least we're all on the same page as we look at the data. Can you interpret that for us and tell us what it shows us?
This shows fluctuating temperature and carbon dioxide levels as determined by the Vostok ice core data. There's some other data from the Antarctic ice core that goes back 800,000 years, but basically the same thing shows up. Now, if at first glance, you might say, oh, they correlate. They go up and down together. And the answer is yes, they correlate. But correlation and causation are not the same thing. And this particular data set seems to me to be the most compelling detrimental set of facts to the whole global warming narrative. The cycle that you see there is roughly about 100,000 years. And Milankovitch in the early 1900s postulated that this was due to changes in the Earth's orbit and also the axial tilt. And there's actually a collection of different cycles for the precession of the Earth's axis and for the change in the Earth's orbit, going from more elliptical to more circular and back again. The change in the orbit is driven by the 2 really large planets, Saturn and Jupiter. And they have different cycles. So it's not exactly 100,000 years. It varies depending on what the relative position of those 2 planets are relative to the Earth. But that's what's believed to be causing these repetitive cycles. And the reason why I think this is a killer for the global warming narrative is that if you look at this graph, when CO2, the red curve, reaches a maximum, the temperature has already turned around and is starting down again. If the CO2 narrative were correct, at the high level of CO2, the temperature should keep going up. but it doesn't. It comes back down. And similarly, at the minimum, when CO2 is at a minimum, temperature should continue to drop, but no, it turns around and starts back up again. So this is completely backwards. Everywhere I look, everything is backwards to the CO2 narrative.
Yep.
But the other real significant issue here is that the CO2 is delayed from the temperature data by, initially a lot of people were saying 800 years, and the belief is that relates to the time constant for the oceans to mix the deep water with the more shallow water. But there's a man named Glassman that did the most rigorous analysis of this data that I have seen. And basically what he did was to statistically take the two curves of CO2 and temperature and slide them back and forth relative to each other, and finding that point where the correlation is a maximum. And that occurs for a delay of 1,073 years. So I'm not sure that I believe that kind of accuracy, but certainly on the order of 1,000 years or 800 years, as many other people have said, the CO2 is delayed from the temperature.
Yeah.
You can't possibly argue that CO2 is driving temperature. It's the other way around.
That is a devastating blow to the mainstream narrative. The fact that one is the horse and the cart are the wrong way round, effectively. So it's temperature leads CO2, not CO2 leading temperature.
If you go back to the slide 4 for just a moment, there's one other thing I can point out to you.
Yeah.
In the lower right-hand corner, there's a red circle, and if you look closely, there's a little black dot.
Mm-hmm.
Okay, that little black dot is the expanded time scale that shows up in slide 13. So yes, it is an expanded time scale, but the only point I would make is that the proxies that people have used for determining CO2 and temperature over a scale of hundreds of millions of years is not going to give you the resolution that we have been able to get from the Vostok ice core data.
Okay.
So to the extent to which the Milankovitch cycles really explain the data that you see in the Vostok ice core data, I would have to believe that that same phenomena is going on. Saturn and Jupiter have been around as long as the Earth has, and they've been pulling the Earth's orbit similarly through all of that time. If we had the resolution, I would tend to believe that you would see the same sort of thing.
The key point is that which comes first. So if temperature goes up, CO2 follows, but it destroys the argument that CO2 drives climate change, doesn't it? I mean, that's the point to extract out of that. If temperature is moving first and CO2 is reacting to it, then CO2 can't be driving climate, which is another central assumption of the mainstream narrative.
So the other thing I would add here is that there's a very plausible reason that this type of relationship exists, that the CO2 lags temperature. And that is that there's some sort of equilibrium between CO2 in the atmosphere and CO2 in the oceans. And the water will be able to dissolve CO2, but the amount of CO2 the water can absorb is temperature dependent. And as the oceans warm, the water can hold less CO2 than when it's colder. And I know you British like warm beer. Those of us in the US like cold beer. But when beer warms up, the CO2 comes out. A lot of people have that experience. And so it's perfectly understandable that this would be the relationship. To argue the other way, I think is much more difficult to do. One other point I'll make is that one of the challenges facing science is that you can never prove that a theory is correct and true. You can accumulate more evidence and more theory and explanation and make it increasingly plausible over time that a particular theory is in fact true. But you can never be certain that there isn't some surprise lurking in the future that would change the scenario. However, you only need one piece of evidence to falsify a theory. I don't know whether you're familiar with Karl Popper on the falsification requirement for something to be a valid scientific principle or theory. But one issue is enough to disprove a theory. You don't need a whole lot of stuff. You just need one.
Yeah.
The last point that I wanted to make is I circled the recent increase in CO2. The CO2 level over the Bostock ice core data is varying from 180 up to 280 parts per million over and over and over again. And people will say, yeah, but CO2 is higher than it's ever been, certainly over this kind of time scale. And this is a disaster. But slide 14 takes the Bostock ice core data and just plots a correlation between the temperature and the CO2. And yeah, they do correlate. They go up and down together. So the graph on slide 14 shows a bunch of dots that corresponds to the plots of the CO2 and temperature data plotted against each other with a line drawn through them that, yes, they correlate pretty highly.
Yep.
The time delay doesn't figure on this particular graph. But if you look at the 410 parts per million that we have today, it's a point over on the extreme right. You see the dotted line that goes over to that. But on the temperature scale, this is right in the distribution of the existing temperature data over the 420,000 years. Now, if the 400 parts per million were a catastrophic problem, the point on the extreme right at the 410,000 would be at the top of the graph, extrapolating that red line up to the top, and it would be a vastly higher temperature, but it's not. Again, a major problem for belief that CO2 is driving Earth's temperature. It doesn't fit.
All those four assumptions within the mainstream narrative telling us that doom and gloom is around the corner unless we all stop driving and reduce our energy requirements. This narrative is just not true. And thank you so much, David, for sharing your knowledge to explode these myths. And I really urge any listeners or any people that are sitting on the fence in this issue, maybe to try to avail yourself to the facts. And David's website is a great resource for that, climateilluminated.com. I urge you to visit that. But it's really important for us to think for ourselves. And if we see a fact that contradicts a claim or an idea or a theory or a narrative, we must discount the narrative. We must at the very least question the narrative and say this, there's something wrong with the narrative. It's not exactly true. But then with the mainstream narrative on this climate change thing, the more you look into it, the more you find that it's completely back to front.
There's one last slide that is worth looking at just because it gives you an interesting perspective. Comparing a pile of rice grains to the atmosphere, if you happen to have 800 or 85,800 grains of rice per air molecules at 373, it's a little out of date, it's a little less than 400. That would give you 32 grains of rice for CO2. The human contribution is generally, I think, accepted from what I've seen at about 4%. That leaves you with 1 grain of rice for the human contribution. Is it possible that 1 grain of rice could be influencing the 85,000 others?
Well, David, thank you so much for joining us.
Okay.
Do you want to just sell your website and tell people a little bit about that, and resources to help educate themselves on the issue?
My friend Terry Gannon and I had been studying this issue since I retired in 2012, and mostly Terry put together a website, climateilluminated.com, that has a very extensive amount of data on a whole wide variety of subjects. Encourage anyone who might be interested to visit it. I think that there's a whole lot that we don't know. There's a whole lot to learn, but certainly what we have explored runs completely counter to the CO2 narrative, prominent in the major mainstream media. I'd like people to think for themselves, look at some of the data. A lot of this is fairly easy to understand. There's no equations in anything that I had presented. The data is available. There is conflicting data. And one of the more alarming things that I worry about is there's evidence of substantial amounts of fraud going on with people changing the data. NASA and NOAA going back and changing temperatures in 1900 to make it look like there's more warming than actually occurred. So you have to be a little careful about what you look at, what you're willing to believe, but think for yourself.
Indeed. And there's
the way I would leave it.
Well, thank you so much for that, David. And, there are issues like the Climate Gate leaks and other bits of evidence that we can look at that point to foul play. And I would suggest to any people out there on the fence that if we do, think for ourselves and look at the facts, there's the only obstacle we have to arriving at an understanding of the truth of how climate works, or perhaps more accurately, the lie of the official story. Because, as you said, it's very difficult to be very certain about climate and how it works. But we can be certain the official story is not true just by looking at the facts of reality. But the difficulty is overcoming what everybody else around us says and what the governments say and what all these so-called impressive scientists are saying. We mustn't let the appeal to majority and authority count as evidence in our thinking, because it really isn't. One person can be correct and a billion other people can all be wrong. And it's very important, I think, for people to grasp that. So thank you once again, David. Thank you very much for listening. And I'd urge you all to visit the website, lawfulrebel.com. Plenty more there on how to bust all these myths within the mainstream narrative and what I call the matrix. Thank you all for listening, and join me again once again on Lawful Rebel TV.
Change you want to see. Be the change you want to see.